Hi class, we're going to continue our lesson on 7.3 day 1. We're solving polynomial functions using quadratic techniques, most oftentimes with factoring. So we talked about this in chapter 5. It was a while ago, so we're going to bring this back to your memory again. But when you see the sum or difference of two cubes, those can always be factored. They factor down to a binomial and a trinomial. And then with these two, now we're eventually going to solve, because we are going to get 3 answers. Our degree is 3, so we know we should get 3 answers. So as I've mentioned before in previous videos, whenever you see two terms, the first thing you should think of is this the difference of two squares? Because a lot of times it is. If it's not, now think to yourself, I wonder if it's the sum or difference of two cubes. This one is that case. It is the sum of two cubes. So we're going to factor it down here. So the first thing we have to do is we must define what A and B are. A and B is going to be the ticket for solving this equation. So A is always the cubed root of this number. So what times what times what is x cubed? The answer, x times x times x is x cubed. So the cubed root of x cubed is x. B is the cubed root of our second number. So what times what times what is 343? The answer to that, 7 times 7 times 7 is 343. So the cubed root of 343 is 7. Now that we've labeled what A and B are, it's really just as simple as putting it into this equation. So our first one is a binomial of A plus B. A is x, B is 7. So we have x plus 7. Now we have a squared, so a is x, x times x is x squared, minus the product of a times b, so minus x times 7, which is 7x, and then lastly we have plus a b squared, so plus 7 squared, and 7 squared is the same thing as 49. Now in chapter 5, here's where we ended. We were done at this point. We circled our answer and moved on. Now we're going to go further because we want to know what x equals. So what we're going to do here is we're going to set each of these two factors equal to 0. So x plus 7 equals 0, and x squared minus 7x plus 49 equals 0. We'll do the easy one first. This one we can take care of very, very simply. X equals a negative 7 when you subtract 7 from both sides. So there's one of our answers. Class, the next one, when we do the sum and difference of two cubes, this trinomial here can never be factored. So don't even try, it's impossible. So you can do it one of two ways. You can solve for x by completing the square, or you can solve for x by doing the quadratic formula. I definitely recommend doing the quadratic formula because I think it is significantly easier, but either one will get you the right answer. So when we use the quadratic formula, we have to define what a, b, and c are. A is the number in front of x squared, which is 1. B is the number in front of x, which is a negative 7. And c is the number that's our constant term, which is 49. So let's refresh ourselves on what the quadratic formula is. It is a negative b plus and minus the square root of b squared minus 4 times a times c all over 2a. I definitely recommend that you memorize that. It is on a poster up in my room, so if you ever need to refer back to it, you could always look on that wall in my room, but it is something that is valuable to memorize. All right, let's find where these other two roots lie, because we know we should get 3. One of them is right here. We need 2 more. So a negative b, a minus negative 7. A minus 7 is a plus 7. Plus or minus the square root of b squared. So a negative 7 times negative 7 is a positive 49. Minus 4 times a, which is 1, times c, which is 49, all divided by 2 times a, and 2 times 1 is 2. So now, class, all we have to do is simplify here. A negative 4 times 49, we're going to do that part first. Let me get my calculator out, sorry about that. A negative 4 times 49 is a negative 196. So now we have 7 plus or minus the square root of 49 minus 196. That number divided by 2. My radical simplifies to get the square root of a negative 147. So all of this makes a negative 147. So we have 7 plus or minus the square root of a negative 147, that number divided by 2. So at this point, you see if you can simplify your radical at all, and you can. The negatives, or the square root of a negative 147 breaks up into 7 multiplied by 3, sorry, 49 multiplied by 3 multiplied by a negative 49 times 3 times a negative 1. So what can you take out? You can take out the square root of 49 to make a 7, and take out the square root of negative 1 to make an I. So you have 7 plus or minus 7I square root 3 stays underneath the radical, all divided by 2. So as messy as that is, class, those are your two other answers. Our first one was right here, in x equals a negative 7. And the other two are 7 plus 7i squared 3 over 2 and 7 minus 7i squared 3 over 2. So there's our three answers. As you can see, these two here are imaginary, so those don't cross the x-axis. So you just have one, and that's at a negative 7, which is right there. All right, as gross as that is, I want you guys to try that on your own. You guys do number 8. It's going to be the difference of two cubes. Try to factor those two into this binomial and this trinomial. Then solve that trinomial by using the quadratic formula. It gets kind of messy, but as you do this more and more with more practice, it definitely becomes easier as you go. All right, let's see how you did. A is the cubed root of this number, which is 2x, because 2x times 2x times 2x is 8x cubed. B is the cubed root of 27, which is the number 3. So once you have that, you simply put it into your formula. A minus B, which is 2x minus 3, times A squared. 2x squared is 2x times 2x. And 2x multiplied by 2x is 4x squared. So that could be one error that some of you had. Hopefully you did not make that error. But when we have this a squared right here, it's 2x raised to the second power, which is 4x squared. Then you have the product of a times b. So 2x times 3 is 6x. And then you have plus b squared, which 3 squared is 9. So this is our binomial and our trinomial. Our binomial is easy enough to solve for x. If 2x minus 3 equals 0, then 2x equals a positive 3, and x equals a positive 3 halves, solving for x. So there's one of our zeros. The other two lie in this mess, and it can be kind of gross and disgusting. But we can solve it by using the quadratic formula. So a is the number, we're doing this here, a is the number in front of x squared, which is 4. B is the number in front of x, which is a positive 6. And C is our constant term, being a 9. All right, let's do this thing. So we have a negative b, a negative 6, plus or minus the square root of b squared, which is 6 squared, which is 36, minus 4 times a, which is 4, times c, which is 9, all over 2 multiplied by a, and 2 times 4 is 8. All right, let's simplify this. This right here becomes a negative 144. Multiply a negative 4 times a positive 4 times 9, you get a negative 144. So now we have a negative 6 plus or minus the square root of 36 minus 144 all over 8. So now further simplifying our radical, 36 minus 144 is a negative 108. So now we have a negative 6 plus or minus the square root of a negative 108. That number divided by 8. The square root of a negative 108. Oopsie. The square root of a negative 108 is the same thing as 36 times 3 is negative 1. So the square root of 36 is 6. The square root of a negative 1 is an I. And then the square root of 3 stays underneath the radical. So we have a negative 6 plus a minus 6I squared all over 8. This would be our answer if we can't reduce. However, hopefully you saw this. This can reduce and this can reduce. So if that's the case, make sure you do that. You can divide everything by 2. So you have a negative 3 plus and minus 3I square root 3 all over 4. Whew! Those are our other two roots. So x equals that 3 halves that we were talking about up here. X equals 3 halves, and the other two roots are imaginary at a negative 3 plus and minus 3I square root 3 over 4. So our only real solution, it crosses once at a positive 3 halves right there. So as you can see, it gets significantly more difficult when you throw in the sum and difference of two cubes. However, difficult, yes. Impossible, absolutely not. So hopefully that makes sense. Hopefully you can do that on the worksheet coming up tomorrow. If you cannot, be sure to ask me questions on those ones, or ask me questions on the actual factoring ones too. I want to help you out whenever I get the opportunity, so please feel free to ask me questions whenever you have them.